Hi, this is Minzok, and I'll explain about the home taking question. So there is the diagram for before collision. Basically, we have the 2 kilogram and 3 kilograms ball. 2 kilogram has the velocity, which is 5I plus 7J, and 3 kilogram mass has the negative 1I and negative 3J velocity. So the equation we have to know is the initial moment equal to initial final momentum, and since the that is the perfect elastic collision, initial momentum and the final momentum should be equal, which is fully conservation of the momentum. Also, there is the condition I got. First condition is that the speed of 2 kilogram mass of final velocity is the square root 50 meter per second, and second condition is 3 kilogram mass traveling at theta equal 329.77 degree, and the other condition is after collision it should be positive x-axis. So this diagram is for after collision, and I assume that since the x-axis should be positive and 3 kilogram mass should be go down like x positive and y negative, I assume that. So from this graph I can define that 329 degree 0.77 of the counterclockwise degree of the 3 kilogram mass, and 2 kilogram we can define x component of the velocity is square root 50 cosine theta, y component equal square root 50 sine theta. So it's the important equation I'm going to use to solve the question, and this is the momentum, and this is momentum for the x component. So m1 should be 2 kilogram, v1 should be 5I, m2 should be 3 kilogram, v2 should be negative 1I, and m1 should be 2 kilogram as I said, and mv dot should be square root 50 cosine theta, which we don't know about the theta, and 3 kilogram velocity is second theta cosine 329.77 degrees, and y component is exactly same, only the difference is the velocity of the y. And from two equation we can define velocity, because since the velocity is the exactly same from the two equation, it's not about the specifically x component or y component. Velocity is the same, and only difference is cosine and the sine degrees to define x component and y component. So when we have the two equation and we got the simplify, and finally we got that number and that number from each component equation, since v is exactly same value, I can make that equation. So to solve that equation, I did the simplify, and these are all those number for simplified number, and finally I got this equation, cosine and sine, and we can divide by two equation, which is cos y equal number times cosine theta and sine theta. And when I plug those two equations on the graph, I can find out the intersect, which is x equal 116.08131 and y value. So since theta should be value of the x on the graph and also intercept value, that's why degree gonna be 116.08131. So to find out velocity, we can plug this data, one of the x or y component of the momentum. So I used the x component first, and the initial component is exactly same, and I plug the number from the exactly same equation from there I explained, and when I simplify that, I can find out the velocity, which is the 5.00021 something that number, approximately 5.01. So to check which velocity and theta is correct, I can put all the theta, value of the theta and value of the velocity on the y component momentum, and I found that I moved that part, the right part, which is the final momentum, to the left side, and when I solved that, I got a 0.00001, which is approximately 0. So velocity gonna be approximately 5.01, and theta gonna be 160.